Hi, today we're going to talk about early numbering systems and we're going to focus on one particular kind. It's called a positional system. Now, just so you'll understand, there were lots of other mathematical systems around, or numbering systems around. Uh, an example is of one that's not a positional system would be the Roman numeral system, where each symbol stood for a particular value, but they didn't really have any, where they were placed inside the writing of the number had nothing to do with what they were. Um, we want to study the one that is most commonly used. Well, it's a standard in Western culture now, and in fact, most cultures. And it's a positional system that's called the Hindu-Arabic system. Now, the reality is, I don't know why it's called Arabic. Well, I do know why it's called Arabic, but it's kind of a cheesy thing that happened. It was actually developed in India, and that's why it's called the Hindu system. And the Arabian traders of the Middle Ages adopted it because it was a much easier way to keep track of computation. And when the Europeans, during just prior to the period where we had the religious wars in the Middle East, uh, well, they started noticing this, and they said, "Gee, that's a really good system." And well, it became the Arabic system because, well, we thought it was developed by the people who lived in Arabia. It wasn't. It was developed by the Hindus. So we have renamed it the Hindu-Arabic system. And it's a positional system. And by that I mean that the values have the location within the number defines what the numeral is worth. So we're going to look at how this is written in expanded form. And we're going to take a look at a couple of other number systems. The Babylonian is kind of interesting. And then we'll look at the Mayan. And Mayan is a little different. It's going to stretch your head just a little bit. Okay, we can write any number that you want using a fixed set of digits. We use 0 through 9. And you can look at them and see some similarities. Like, if you think about it for a while, what's the difference between, well, let's try one. Let's try the number 2 and the number 7. Do you see similarity? I certainly do. The difference is there's an extra line in here to form the 2. Now let's look at 3, and then let's look at 8. Do you see how they were probably built? And then let's look at 4, and let's look at 9. Do you see a similarity? Well, if you think a minute about it, let's see if I can make it look that way. If you take a number right here, that looks like a 4. So what we basically did is took the 4 and just kind of completed the top. So that became a 9. Okay, so we see how these things developed. Now, you're right, 0, 1, and 9, well, they're out there for us. Now, historically, the last of these digits to develop was the 0 because it challenged the brain to think about a symbol for, well, lack of something or maybe nothing. But we developed it over time and we worked on it pretty well. Now, Hindu-Arabic numbers are written in this expanded form. Okay, so when you're talking about the number 663, that means 6 hundreds, 6 tens, and 3 ones. So we could write it like this: 6 times 100 plus 6 times 10 plus 3 times 1. Or we could change things a little bit. You see, that 10 to the second is 100. So this and this are the same thing. And this are the same thing. Now, I will tell you something. I would have written this as 3 times 10. Well, no, wait a minute. 2, 1. What's going to come next? 0. And so what that means, what that would tell us is 10 to the 0th power is simply 1. Okay? So let's see how we can fit this together. Okay, the Hindu-Arabic system is called positional because it lets you write any number based on these powers of 10. The first number is 1, which we just already know is 10 to the 0th power. And we have the second digit is the tens, and the hundreds, and the thousands, and the 10,000s, and the 100,000s, and so on and so forth. So basically, we can write any number, no matter how big it is, using this system. Well, I will challenge you, if you remember your Roman numeral systems, kind of try to figure out how to write 107,311 in the Roman numeral system. Good luck. It'll take you a while. So if we want to write 3,407, we would write it as 3 times 10 to the third, plus 4 times 10 to the second, plus 0 times 10 to the first, plus 7 times 1, or 10 to the 0th power. Now, do you see what happened here? We had to add something brand new to the system. And that is, sometimes we have to include this whole, this 0. And this is what made 0 absolutely necessary, because positional systems depend on the value of zeros to tell us how many tens there are. Well, if there's no tens, you got to write in something to hold that spot. And we ended up using a 0. Okay, how about this one? 7 times 10 to the third, plus 5 times 10 to the first, plus 4 times 10 to the 0th power. I'm going to keep putting that 0 in there, just to keep reminding you. Okay, so basically that's a 7 times 10 to the third. 10 to the third, that's 10, 100, 1,000, 10, 100, 1,000, so it's 1,000. Okay, so this means 7 thousands plus 5 tens plus 4 ones. So that would be 7 times 10 to the third plus 5 times 10 to the first plus 4 times 10 to the 0th power. So that would be 7,054. Notice we've got that 0 in there to identify the fact that there's no, well, we had to have that in there because up in here we didn't have a 10 to the second power. So we have to fill in with that 0 for it. Now here's the Babylonian numbering system. They use powers of 60. So if they write a number like, well, we'll use our numbering system. 354, that's 4 ones, plus 5 60s, plus 3 times 60 squared, which is 3,600. So now to find out that value in our numbering system, we take 3,600 plus 5 times 60, that's 300, so that would be 3,900 plus 4. So this would be written in our system as 3,904. Now, you may look at me and say, who cares about the Babylonian numbering system? We never use it. Oh yeah, see that clock on the wall behind me? Yeah, that's my school teacher clock. I stole it from my wife's classroom many, many years ago, and it's lived with me ever since. Now, here's the question. How many seconds are in a minute? 60, right? Why did they choose 60? Who developed it? Notice right up there is a 60. Time was developed by the Babylonians. That's why we have 60 seconds in a minute. One more. How many minutes in an hour? Well, again, 60. So we got, well, that's where we're stuck with that. And if you think about it, well, you guys are used to that. So understanding this Babylonian numbering system Well, you already do. If you understand time, you understand how the Babylonian numbering system works. So let's look at this one. This means VV, that's 1 plus 1. So that's 2 times 60 to the second power, because see, this one is the 60 to the second power. This is 60 to the first power. And this is 60 to the 0th power. Which is the same as 1. So this is going to be, let's see, 1 and 1. That's 2 times 10 to the 60th squared. Plus, well, that's a 10 and a 1. So that would be 11 times 60 to the first power. And this is 10 and 10 is 20. And 1 and 1 is 22. So this is 22 times 10 to the first power. Now we multiply all this out and we find out that this value in the Babylonian system was the same as 7,882 in our numbering system. But you see how this really works the same way ours does, except instead of having 60s, we have 10s. And you may look at it and say, well, 10's are a lot easier than 60. Well, frankly, that's because you were taught that all the way through school. Now, granted, having 60 digits can be kind of a problem. And they went to this approach to make things a bit simpler for them. But it helps us understand why they did that. Now let's take a look at this one. This is the Mayan numbering system. Now, they don't have our numerals, 1, 2, 3, 4, 5. They have these symbols. That's a symbol for 0. That's a symbol for 1, for 2, for 3, for 4. That's 5. This is 5 and 1 more is 6. 5 and 2 more is 7. 5 and 3 more is 8. 5 and 4 more is 9. Then 5 and 5 is 10. 10 and 1 more is 11. 10 and 2 more is 12. Up to 15. 15 and 1 more is 16. 17, 18, 19. They use 20. Now you may look at me and say, why in the world? Well, wait a minute. Why do you think we use 10? It's real simple. Look at the camera. How many fingers you got? You got 10 of them. So they were using 10. We use 10. The Arabic system uses 10 because, well, we got 10 fingers. What do you suppose the Mayan system was based on? Fingers and toes. 20 of them. So here's the thing that's interesting. When you write this down, they wrote their numbers vertically. They didn't write them horizontally like this. They wrote them up and down like this. And frankly, that's not nearly as uncommon as you might think. So let's write this number. Okay, that's, let's see, 5, 10, and 4 is 19. And that's 0. And that's 5, 6, 7. And that's 5, 10, 12. So this is, let's see. This is going to be 12 times 1. This is going to be 7 20s. This is going to be no 360s. And this is going to be 14 7200s. So suddenly we have to add all that up. And in our numbering system, this symbol would be the same as 100,952. So this symbol and that symbol have the same meaning. What's the advantage of the Hindu numbering to the Mayan system? We write big numbers with not many digits. On the other hand, you had to learn 19. Now you had to learn 19 numbers. Now you remember how much trouble you had learning the multiplication tables with only 10 numbers? What happens if you got 20? See the problem? You got more facts to memorize. So what's the trade-off is this. Do you want smaller numbers up here with a lot more memorization, or do you want bigger numbers with less memorization? Well, in our part of the world, we chose bigger numbers with less memorization. And that's why we ended up with it. Okay, I hope this helps you understand a little bit about where these numbering systems came from, and you can start to see how this fits into how mathematics fits into the history. We are going to go a little further with that here in just a second. Thanks. Bye.